Uh, Let me share my screen.
Sure.
Okay, I believe that you can see my screen, right?
Yes.
Okay. Okay, thank you very much, Dr. Chitini, for introduction of myself. That's really great. And today's topics will be about the insight from mobile phone big data in the context of the COVID-19. I believe that somebody said that this month still 13 months of 2020 because we start with the COVID-19 and then still it's going on. So somebody said like, okay, that still continue. We are still not start the new year yet. And because of this COVID-19, last year we have affect a lot of things like we cannot travel around, our behaviors or how our life is actually changed a lot, including me. Actually, I plan to, I actually have a lot of trip last year and then it was canceled. And then everyone have to work at homes, including me. And with that, still have a lot of chance that we can still doing something even we are at home. And then the COVID-19 analysis by using mobile phone data is one of that. So I have chance to work with many aid agencies to utilize mobile phone data in order to tackle or provide response or monitoring the mobilities of the people in order to provide some response on the COVID-19, even though it's not direct response, but it somehow can help on that. Let's say one example is that uh, you might have seen from the news in the recent days in Thailand that once they got once they found a confirmed case, they will ask for the timeline, right? So once they ask for the timeline, sometimes you get like very cooperative from the confirmed case, but sometimes that guy or that person just said they don't know, they forgot, they don't want to say anything, or they completely forgot what they have done in the past 5 days. So that is actually not only Thailand, that also happened in other countries that I also work with. So that's why they're trying to use mobile phone data, because when you have the mobile phone data, then you can see or you can trace the mobilities of that person, even though whether that person is actually live on the timeline, but then this mobile phone data will not lie to you. And then with that, we can see the trace and then the movement. Then we can use that information to tackle, to see which location that person or that confirmed case actually passed by, and then can do some kind of the mitigations or response. So that is just one ideas of using mobile phone data. And that come to my topics today. So before we go to the details of the COVID-19 case, at first I believe that we should know about the mobile phone big data first. So why we are talking about mobile phone big data? So big data has actually been with us since I believe the 2013 that very popular, and then many people actually like want to do something on big data. But I believe that not all the people can do because a lot of issues. One thing is that data access. But anyways, like in our case, we're focusing on mobile phone data. Why we are focusing on this one? Because you can see that the number is mentioned that like 7 billion cellular phones available in a day. And then I believe like all the countries, many people, most of the people also right now carrying the phone. So once they're carrying the phone, they use the phone. And then the phones can also collect some of the data. Then we can see the movement of the people, exact movement of the people. And then we can use that data for some other like social benefit. And then the things that make this data is different from the satellite data is that from the satellite data, let's see if there's some kinds of the earthquake, what you can do is you can use satellite data to see which area that actually damaged from the earthquake. But probably you don't know exactly how the people actually affect from that kinds of the earthquake. But based on the movement, based on the reactions that people actually made on the phone, then you can somehow referring to a kinds of the effects or the damage that happened with the people. I can also use some of the video later on as well. Let me stop shares and then let me share again by using another mode that we can have better videos. Okay. Okay. And since 2019, I mean 2013, so MIT already is like said that usually MIT will provide kind of 10 breakthrough technologies that actually change our world. And then since 2013, mobile phone big data is actually one of the breakthrough technologies. It means that with the data from mobile phone, we can use for doing so many things that for good, for social benefit. And when we talk about the mobile phones, so we first need to know about the localization. So with our mobile phone, so how we can identify the location of the phone. So there are actually the two kinds of the techniques. I mean, mainly two kinds of the techniques that we can do the localization of finding the location of the phone. One is the GPS. And then with the GPS, you can get very accurate location data. And then you can have like, let's say 1 second to 5 minutes to 10 minutes, depend on the configuration that you do on the smartphone. And then very precise. However, with the GPS data, you will have to install some of the application. For example, you install Google Map. Then once you install the Google Map also trace your location to send the data to servers. Or taxis or van that they have to install some of the software in order to collect this GPS data. So the problem is that how we can scale this software to the population level. So that is quite challenging. On the other hand, we have another data set that is called CDR, or the call detail record. So this data is actually from the smartphone itself, I mean from the phone itself. So when you make a phone call, it actually generates the data called CDR, or call detail record. Even though you make a phone call, you send the SMS, you play the internet, that will generate the data communication. And then with that data, operator need to collect that data in order to do the billing, so that you have to pay them every month. So this data will be collected anyway for the billing purpose. But in addition to that, this data also contain the locations of the handset at the cell tower level. It means it's not really exact as the GPS data, but it will be the location of the cell tower that the mobile phone is actually registered at the time of the action or activities. And with these data, the benefit of this data is that one thing is that it's actually cover almost entire of the population who have the phone, and usually more than 50 or 60% in every country people carrying the phone. And then the data is available for sure because operator need to collect these data.
Dr. Apichon, can you go back to your previous mode of sharing the screen probably, because now we see two screens.
Oh, really?
Yeah.
Okay.
Yeah.
Let me check again.
We can see the next slide, that mode.
Okay. How about now?
Yes, now it's okay.
Okay. Okay. Then for more details, for the CDR data itself, actually like this. So for example, like from 8 a.m. you make a phone call, and then when you make the phone call, we can have the data, and then it generates the CDR data. And then you're moving around, like at 10 a.m. you go to somewhere, at 11 a.m. you go another place, and then at 2 p.m. you go another place. And then at 5 p.m. you again make another call or send the SMS. Then we can have the data at that time. So you can see that like with the CDR data, we cannot get the exact locations and also like a really detailed location that you pass. However, it also depends on the type of the phones. Usually in the past, like when we use the feature phones that people usually use just a phone call and SMS. But right now, many people use smartphone and then they play internet on the smartphone, or they use the internet on the smartphone. So in that case, smartphone always connect to the server. So in that case, the data is actually generated more than before. So we can have very much more detail than in the past. So this data is actually really important. And then for the COVID-19, what we're focusing is we use these CDR data. And then in order to get some more idea for use, so this is the data, one example of the data from the GPS that we collect in Japan. And then this is the day that Japan has the earthquakes on 2011. And then you can see that there's a lot of movement, very details along the road. And then you can see the big link, the white one here. That is actually the main train line in Tokyo areas. And then you see it's become lighter after some time because it's already past the commuting time. And then you will see that after around 2:30, then the earthquake happens. Then all the points actually much less, and then moving slower and also moving toward to the left, because actually they're kinds of the announcement for the possible tsunami. So people actually move toward to the mountain side, and then all the transportation stop. So people have to walk. And then if you watch this one after sometimes after 24 hours, you can see that the movement of the people start moving faster because some of transportation also back in operations, or even for the train. So with this data, you can see that when something happens, people carrying the phone, and if we have the data, then we can really see how the people behave, and then how the effect is actually happen to the people itself or to the human. Something like this. This is an example of the GPS data, and then you see that the detail is very very accurate along the road, along the train line. But on the other hand, this is another data that from the CDR data, and then you see the light spot along the areas, and then this light spot is actually the cell tower data. So you don't see very much movement. You just see that, okay, there are a lot of people active at particular cell towers. And then here is actually kind of like a city center. So there's so many cell towers, something like that. And then you can probably see the link among the area as well. So based on this video, you will see that, okay, it's not really detailed and a bit difficult to handle this kind of the CDR data. However, with some of the techniques or algorithms that we develop, I believe that we can play the video here. Oh, okay. Probably there's some issues that video cannot place, but basically with the big data and then with the interpolation techniques, then we can see it's a lot of movement. We can see a lot of movement, and then the movement will be very much more detailed than just the CDR that I show you. And in addition to that, when we're talking about the CDR data and then the data from the smartphone, then people might worries or having some kind of the concern about the privacy, because okay, they just worries about being tracked by the government or something. So every time that we work with this kind of the data, we have to do something that is called anonymizations, or it's called de-identify. It means that based on the identifiable informations like phone numbers, emails, that is the unique IDs of the smartphone, with that information, it actually will be hatched or will be randomized to a kind of the random IDs, which is just one-way hatching. So it means you cannot revert back to the original values. For example, you can see on the button that like for the original value is like this, and after you doing some hash, then you will get very long hash code that cannot revert back to the original value. And then this is the data that we work with, something like that. So this is one way that we do in order to ensure the privacy of the people. And also when we operate or when we process this kind of the data set, we actually like the data and then the hardware that used for the processing. This is actually at the on the premise of the regulators or on the premise of the government department who actually responsible and then having kinds of the authorized to handle this data. And then once we de-identify, then what we have in the data that we can do or we use for the analysis is that we will have the kinds of the random ID, and then we will have time, and then we will have like let's say the location areas, and then cell tower ID, and then the durations, and then the activity type, whether voice, SMS, or data communication. So with this data, there is no information that link to the human, to the exact person. And then with this data, you see that there is actually no information about the exact location of the cell tower, for example, the latitude, longitude. So when we do the analysis, we need the CDR data, and also we need the kinds of the base station data as well in order to map the exact location. Because in the CDR data that we are talking, it only contains a cell tower ID. There's no latitude, longitude. That's why we need the base station data in order to combine and then matching like exact like cell ID with a cell ID so that we can have the new data set that contain the latitude, longitude. So with this data that already combined, so we will have hash ID, times, and then the location. Then this data is actually ready for the analysis. And to give you bigger ideas about how we handle these kind of things, so I put one scenario for the data acquisition and processing. So basically, you will have the CDR data, and then the CDR data can come in many forms. For example, it can be directly from the mobile phone operators, or it can be provided by the regulators or authorities who are actually responsible for this kind of the data for particular countries. And then normally, once we have the data, if the data come in the raw forms, then we have to use anonymization software in order to anonymize. That I already mentioned, that is the process to de-identify, to remove the identifiable information. And then that data will be uploaded into the authorities who handle this data and then intend to process this data. So in this case, will be the regulators. When we talk about the regulator, it means the telecom regulators. In Thailand, we call NBTC, and then in other countries, they have a different name. But basically, there will be like authorities who take care of or to regulate the spectrums in the countries. And then usually this type of authority is actually having authorized to handle this kind of the data set. So the data we will automatically put on these servers based on the data pipeline, like every day or every week, depend on the how they negotiate. And then they're also having kinds of like Hadoop or big data servers that work as a kinds of the cluster. So there's many machines actually combine together so that it can run, it can handle very huge data. So huge data that we are talking right now is actually like not just millions of the record. We're talking about 1 billion or 10 billions of the record, and then the data is actually increasing every day. So if you want to design a system which can accommodate the data over 3 years, probably you have to handle over 100 million record. So how we can handle that data? So that part will be in the big data related stuff. And then the system that we use is called Hadoop. So we use Hadoop and then Hive for this kind of the clusters. And then the process will be run automatically by using a software called Apichon Witayangkurn that mainly for the data flow and then automate workflow. And then once the data is in the big data cluster, then we have the software that we developed in our research group that is called MobiPack. So in the MobiPack, there are the series of the software that can analyze the CDR data. For example, it can create the statistics, it can do the interpolations, it can output some sort of the origin and destination, it can produce the indicators that we can use for the COVID-19. And then with these data, it output the data into the database. And then we have we use the web applications that a kind of the dashboard is called Tableau. And then with Tableau, we create the templates of the dashboard so that it automatically read the data from the database and then produce the results to the officials, to the officers, or to the other team who actually want to serve this data. So this is the overview of all the scenarios of how we handle this kind of the mobile phone data. Actually, the most difficult part is to negotiate how we can access to the data. But most of the case, that will be the task of the regulators in particular country. That's why when we work with this data, we work with the telecom regulators. And this is the big data clusters that I mentioned. So basically, we have at least 4 machines work together, and then we install the software called Hadoop and Hive. And also we use the special package is called Horton Work Data Platforms, which contain Umbrellas, that is a web-based management that we can control our clusters. And then I also put the specification here. So as you see that in the totals, we have 24 cores, 48 gigabytes, 15 terabytes, and then it have the replications as well. It means with this kind of the clusters, if some of the machine malfunctions or failure, then we don't lose the data. And that is the key benefit of the Hadoop or the big data platform that we are using. So this kind of the frameworks or the structures is that we define this one, and then also we set up this kind of the cluster in many countries, particularly in the African country. So we provide the specification, and then they create the clusters. Sometimes we have to remote and then install the software and then provide the capacity building to them as well. And then in order to process the data, so we developed the software that is open source. It's available on the GitHub. It's called MobiPack. So we have the MobiPack that is called a standalone version. So you don't need the Hadoop in order to analyze this kind of the CDR data. And then we have the Hadoop version in case that you want to process on the the big data or really huge data. So initially developed by the U Tokyo under support of ITUs, and then we have the additional projects. So with the GPSDD that funded by World Banks, and then also some of the funding by Bill and Melinda Gates. So we top up our software with the different modules from time to time. And then the recent one that we add is the indicators that can be used for analyze the probabilities of, particular for the COVID-19. So we have this series of the softwares. For example, anonymization, we also provide in the package for the interpolation to interpolate the point, because the location of the CDI is actually based on the cell tower. So we utilize the load networks so that we can get more detailed movement, and then some sort of the visualization tool as well that we also provide. And then in the Hadoop version as well, we develop the code in the Python, and then if you define the structures of the table based on our documents, then you can run the program, and then you can generate all these results, even OD statistics, some sort of the interpolation as well. So all these software is available on the GitHub. And then this is the recent one. that we develop as the indicators. And then in the futures, we plan to do the similar thing. So we plan to create the different package for particular indicators. For example, right now we're doing something more on the transportation. So that will be the transport related indicator package that we will release soon after we finish the project. And then in this indicators, so it contains like the observations, number of the subscribers, percentage of the subscriber that active in the days, or resident that living in the areas, or OD metrics, or the median distance. Why we have to look at this one? Because let's see that, okay, if there's certain thing happen, for example, COVID-19, the government issue the lockdown, and then people cannot move, cannot go out, then we can easily see from some of these indicators that, okay, we see that, okay, median distance, usually people in these cities travel around like 10 kilometers in a day. But after the COVID, it reduced to just like 2 kilometers in a day. And then even the COVID-19 relaxed, and then you probably still see very less distance in average. But then after 1 month or 2 months, things actually getting recovers, and then the movement distance actually back to the normal state after 3-4 months. So such kind of things can be easily derived from this kind of the indicators. And let's back to the topic. So right now, I believe that you have the overall ideas about the mobile phone big data, what kind of the data and how we can get access to that data. Then here is about like the case of the one country. And then why we have to use the mobile phone data or telecom data is that because the data is generated based on the calls, SMS, and data usage. It contains the timestamp. It have the cell tower locations, and then we can observe the mobility of the people as well. And then it covers all the subscribers. Probably there's some hidden population that, for example, like children in the house or housewife or the elderly people who actually like not carrying the phone. But there are also some other techniques that we can overcome that kinds of the issues. And the objective of this work is that like we want to inform the COVID-19 response effort with the timely information, and then it can be used for monitoring the change and then doing some sort of the policy design. Because in many cases that like the government want to issue certain policies, but they need to find a way to monitoring to have some sort of the information so that they can support or can be support for the ideas or for some sort of the policy. So this kind of the data will help on that, and then can also use for the decision making. And then the benefit of this data is that like it's high frequencies, highly localized because we get the locations, and then it high population coverage. You will see that in many countries, even in Thailand, the government asks to install many software, install this software, install that software, and then have to like always enforce. Encourage is not enough because the people actually like don't want to install anything. But with this data, they don't have to install any software, something like that. And to have overall ideas about the COVID response effort. So here I make actually our professors make this kind of the diagram so that we have very clear ideas about how we can utilize this telecom data for COVID-19. So basically, we will have the raw CDR data that handled by the telecom regulators or mobile phone operators. And then for the individual trajectory data, we do anonymization. Anonymization means we had the IDs, we remove identity data. And then we're doing some kind of mobility statistics or map based on the indicator that we develop. And then with that information, we can use for monitoring socio-economic impact. And then it probably can use to mitigate the socio-economic damage or promoting some sort of the recovery. So actually like agencies like World Bank of Asian Development Bank interesting very much on this kind of thing because they want to see when the COVID happens, how is the economic impact, and then whether it's already recovered or not, something like that. The movement of the people actually one way that we can check that. For example, like sometimes or some policies like government having the campaigns that it's subsidized for the traveling, and then how we can monitoring that whether people is actually travel allowed or spend time somewhere apart from their home, something like that. So these data can also help to do that. And in addition to that, it can be used to monitor or forecasting the spread of the infection. We can easily find, like based on the confirmed case, we can see the clusters, we can see the hotspot, and then we can find the link. And for example, if there's a certain cluster at a particular location, then based on the movement of those people, we can see where would be the next clusters or where would be the next like possible spreading areas based on the movement of the confirmed case that found on that clusters. And then that also linked to the policies in order to contain the COVID-19, something like this. And as the optional, I see that many countries trying to do, but it depends on the regulation and then of the country, whether it's allowed to do or not. But in some countries, in African countries, like in Africa, they're doing this kind of thing. So they actually like, for this kind of the patient or code contract, person tracking, they access to the raw data and then try to find the timeline based on the mobile phone data, and also finding like most call persons that link with that confirmed case or patient, so that they can find the possible infectious, something like that. So that is the idea. And then in our approach, so we want to produce kinds of the actionable statistics about the population movement by link with the certain indicators like number of the subscribers during daytime based on the district and sub-districts, number of the visitors that moving around districts, or like number of the inter-district trip or the median distance. And the case that I will show on this presentation or on this talk is one anonymous country. So I am not allowed to say the country name, but basically it's one country, it's in Africa. And then the poverty rate is allowed 39%. And then in the country is divided into 5 provinces plus, and then 25 districts, and then over 200 sub-districts. And based on this data, we have like 8-week telecom data from 2 major mobile phone networks that cover around 80% of the market share. And then here is the timeline of that country. So we just say like week 0, week 1, 2, 3, 4, 5, 6. So in the week 0, they found the first confirmed case. And then on the mid of first week, the people in the capital cities start working from home. And then in the week 2nd, government issued a lockdown. So everyone have to work at home and not allowed to go out if there's no certain like really important matters. And then in the week 4, the lockdown is actually extended. So it is very common in many countries that after lockdown for 14 days, they extend the lockdown. So this is the kinds of the timeline. And then based on the data that we analyze, we found immediate decrease in the population share of the visitor after the restriction. So it means we see that like very sharp decrease after the government issued the lockdown. So people actually like change the movement and then stay at home. So that's why like the population share of visitor from other sub-district or district is actually reduced a lot. So it means that the people who actually visit the capital city reduce a lot. And then you see that the number is actually reduced and then start increasing just like about of like the day that they extend the restriction. So you see the curve here. Basically, like this is actually common in many countries. So once the government issue the lockdown, people stay at home. But after some time, they get relaxed. For example, after 1 week or after 2 weeks, they start to be relaxed. And then they're just moving around, maybe starting from nearby house, and then try to get back into the normals again, something like that. So this kind of thing is actually, based on this data, we can observe that one. But again, once the government issue the extension, then it's reduced, and then it's getting up again after a week, something like that. And then we can also see the significant decrease in the population inflow from other districts to the capital city. So basically, this gray line is the capital cities. And then usually these kind of the capital cities attract a lot of people from other city nearby, and then even like the city that's not nearby. But after the restriction, so we see like over 40% or 50% decrease because the government not allow people to traveling from city to cities. And then the capital cities are actually like kinds of the target, something like this. And then this is also another example that we see like a little bit slow and then small decrease in the population inflow from the commuting town to the capital district. Commuting towns mean like the city nearby or the town that nearby the capital cities that people usually living or resident, and then traveling or commute to the work in the capital. So we see the reduced, but again, you see this one. This is the area where actually having the airport, and then in the week 1 is increased, and then week 2 also increased. Why this kind of thing happen? It is actually, so once there is a kind of the COVID-19, and then the government start to increase the regulations or tighten the rules in order to go back to the countries. So many people actually that like working abroad or studying abroad, they want to go back. So that's why we see this kind of increasing just like after. That's actually different from the another areas, something like this. And that also happened in many countries as well. And then another thing is like there were change in the population inflow from other districts to suburban. So actually, we see that some of the trip is actually increasing, particularly in suburban area. For example, this one is actually the province capital. So we see more trip because probably like once they cannot work, they cannot go out. The people who stay in the capital city is actually back home. So that's why they go back home, and then it's increasing the trip in the suburban area. And then also some areas actually decrease a lot, particularly the areas where they have the borders. I mean, where the district that having the borders and then the border closed, that usually have a lot of traffic around, something like this. And then there's like a marginal change in the population inflow from other districts to suburban areas. So you see that there's a kind of increase of the inter-district trip to the area where actually like the borders still remain open. So when the border remain open, some other borders already closed, so it increased a lot of traffic. And then actually, the district E is actually later at the later stage is one of the district that actually having a lot of confirmed case, something like this. And also this one is about the change in the distance travel. So we actually see that there's a lot of like reduced in the travel distance in Everett. So usually like people travel really long, and then after government issued the lockdown, it reduced rapidly and still reduce it. So if the government reduce the, I mean stop the restrictions or the lockdowns, and then we can easily to observe that the median distance is actually increased or not. If it not increased, it means the people still not back to the normal yet, something like that. And then this is another thing as well, that kinds of the diverse percentage change in the distance travel from the suburban areas. So it depends on the areas. For example, like the area where the border still opens or reopens, so we see increasing in terms of the median distance, and some that actually next to the capitals or second large cities usually reduce a lot. It means usually what we observe is that the cities actually in the capital or like nearby the capital cities most likely follow the government rules, but the cities or the district that actually, or the province that in the suburban areas are very far from the capital, they tend to have their own stuff, and also like the area where it's actually near to the borders, then there are different kinds of the movement, and then it actually attract a lot of the inter district trip. It means that a lot of people try to visit. So there's still some of the limitation in these things. So so we probably, if we want to get more details, so we probably need to aggregate with other data set, like survey data or the census data in order to get more information. And then we probably look at more details at particular admin levels or much smaller level, something like that. And as I talk, so I just want to, before the closings, I just want to introduce our activities. So our research group is called Spatial Data Commons. So our vision is to support the countries to do the data analysis, particularly on the big, like mobile phone big data. And then here is the area that we work. And then here is me, that we have the technical workshop in Sierra Leone, that we provide the training to telecom regulators of the 3 countries. And then usually how we work is that we have various kind of the stakeholders. So for example, like data controllers who actually provide the secure access to the data. It can be the regulators or MNO. And then we have data processors who actually, let's say, de-identify the data, produce the indicator. That can be the regulators or MNO. And then end user who actually use the indicators. So the indicator or statistic that we are talking is actually already aggregate. So there will 100% no privacy information on that. So the local government or health expert or the economists can access to that data. And then what we do is that we try to help them, like set up the system, provide capacity buildings, try to establish environment so that they can access to the data, they can produce the data. I mean, they can they have the ability to handle that data, starting from installing the system, and then provide training data, helping them in processing at the early step. And then later on, they can continue that kind of stuff and then produce the indicator by themselves. And then they can work with many agencies who actually want to utilize that data. And that's all for my talk. So if you want to see more information, you can access to the link that I provide. And then if you're interested on our software that called MobiPack, then you can access to this link. And then everything is available on the GitHub, and then even the source also open. So you're allowed to use and then to share and modify. Okay, thank you. Thank you, Dr. Chitinis, for allowing me to talk a bit long.
It's okay. It's your session, so it's your time. So I'm quite interesting, as I can observe, like very interesting use of mobile big data for making some informed decisions, because what you have shown scientifically, we have seen like, yes, after some time of the lockdown, people go relax. So it's now like with the mobile big data that can be scientifically proven. So I think we head on to the questions round, and I request our viewers, if you have some questions, you can type in our Facebook Live comment box or in the Zoom chat box. So we will take up some questions. Before that, since we have Dr. Chairath also with us, I will request him to share his success story or contributions towards big data analytics, like because we are talking about big data now.
Okay. Thank you for Dr. Apichon for interesting talk and Dr. Chini as well. So for my part, I think if you're talking about a big data analytics, I think based on my experiences, big data source might be different meaning from Dr. Apichon. Actually, maybe he focused on like mobile big data, right? But most of my case is would be like imaging data and textual data as well. So, well, maybe I cannot say it's success yet for my project. So I just started initial project related to big data actually. So as you guys know, the first step of to collect the bunch of data source that could be like structured data and unstructured data. So right now the structured data on my project is ready to process. But for unstructured data like imaging, scan document, those are the things that we think is still challenging for us. And the current process is try to come up with the optimized algorithm to extract the insight from those kind of data before we process it later in the next phase. But right now, I think big data for my case is so far so good.
Thank you. So I think both of you are like pioneers and like experts in this field. And like from a student perspective, I want to ask both of you, where to begin if somebody wants to start like without any knowledge or like least knowledge about big data. So what skills, programming languages they should be familiar with, and what preferred background do you recommend? Is it only for the computer science backgrounds or any other backgrounds also can think of?
All right. Let me
Yes.
first, actually.
Okay. Yeah. Sure. Yeah.
Okay, I want to take it first. So
Yes. Yeah.
for my case, I think my experience is like computer science, but I think it's not necessary actually.
Mhm.
So, but right now, as you know, Python is some kind of language, the computer language that like the children also has to learn now, right? So
Yeah.
it has to be like the background of those kind of every field nowadays. So maybe at least you should first have some
Focus
like
on.
logical thinking and also some maybe just at least one programming language that would be good. Yeah, for me.
Dr. Apichon, yes. Yes.
Okay, okay.
Yeah.
So basically, if you want to start doing something on big data, it means maybe at first you have to read some of the book. I mean,
Yeah.
that's very common. At least you need to get the ideas. What is the big data? As you've seen that many people talking about big data, they said, "Oh, big data is like this and like that." But then I think less than maybe 10% of them they're actually doing something on the big data. But the big data itself is actually with us for so many years, for so long. But the problem is that we don't have the abilities to do that. So we have really huge data, but we don't have the capability, we don't have the machines, we don't have the software which can process that kind of the data. But after like in the past 6-7 years, we have the new system, we have the new software that allow us to handle that data. So if you want to learn on this kind of thing, so probably you need to start learning something that's that, like for example, the key ideas of the big data, what kind of the software that allow you to handle big data. And then even right now, there's so many software that are available that you can use. and you can utilize for the big data. And then back to the background. So when we talking about like the big data, sometimes it linked with some of the position is called like a data engineers or data scientists that many people like to use. And for the data engineers, actually, like I think it's more on the data side. So you prepare the pipelines, make sure that the data from the data source is actually come into the big data clusters, and then it convert, it transform into a certain way that remove all of the issue or problems and ready for analysis. And then data scientists can access to the data and then produce the data or doing some sort of analysis. And then it can produce even like the final output, or it can produce at the certain of at the level of the intermediate data. For example, like in our case, we produce the indicators, but indicator itself not tell you exactly what you want. But then if you like, you are from the medical areas, or you're from transportation, you are from the remote sensing GIS, you look at that indicators and then you use your own knowledge in your specific domain, then you can actually create something or analyze something. So in terms of the background, so there's some person who actually need to have the basic in the computer science, who handle the data, make sure that the data is ready for analysis. And then there are another person who actually just working on the intermediate data, which not necessarily to access to the huge data. And then they can use Python, as Chairath mentioned, or there's so many libraries available right now. So that is not very specific to the computer science or computer engineers. Even the student from remote sensing GIS also can do. And then Chairath is one of that. So
yeah.
it seems to be no issues, I think.
Yeah, that's why I asked him also the same question. So
Yes.
because he knows he's more fresh.
Actually, my recommendation is to start the big data. You should play around with the sample or small data first. If you can play around with it, it's okay. Then you can start with a little bit bigger than that.
Yes. And actually, like there are a lot of open data right now in many countries, like even in Thailand, in EU, in UK, in US, they are having like open data platforms, and then open data, like government open data. So it allows you to access to really huge data. Then you just have to link those data together. And then in terms of the facilities, there are many cloud software available, like Amazon, AWS, or Azure or Google Cloud, that probably have some link with the student that student can use for free for certain times. Then you can get practice on that. And also in many institutes, they provide the hardware or system for the student as well.
So as we talking about the data accessibility, how readily available are these CDR data? Because these are personal data, I guess, right?
It's available everywhere.
But is it available for research, like
But how you
research?
access the data is actually really depend on the countries. And I would say that like it seems to be impossible, particular for developed countries. For example, like in Japan, we try a lot, but we could not get it because of the regulations. There's some regulations indicate that you're not allowed to do that one. But so that's why most of the case where we work is like Indonesia, Sri Lanka, Bangladesh, and some African countries. So which actually like they allow the regulators to access this data and then use for the social benefit. Because you see that, okay, you are developing countries, you limit a lot of access, and then the government don't have any data to support, to provide information in order to build up the countries. So you have to trade off somehow. So that's why, like for the developing countries, they're more relaxed than the developed countries. So they allow the authority to access to certain data with very limitations. I mean, with a lot of restriction, but they are allowed to do, and then use for the social good, something like that. But in terms of data availability, it's available everywhere.
Available, of course, yeah. It's available, but like not maybe for research or like not to us directly, right? That's what the channel we have to find out. Yeah.
Do you think it's possible in Thailand?
I think it's not possible. I mean, it seemed to be possible, but with the current regulation they just released last year, it seemed difficult. But there are some attempts, so they're trying to do, because I also work with the NBTC as well, in order to let's say like doing some sort of the use case, so that let's say like if this data is available, then what we can do, and then what or how it help the countries in terms of the social benefit. And then based on such information, I hope that they can change some regulation. But again, it's really limited to some of the research group or some of the people who can access to that data. Okay, but we are starting something in India.
Okay, that's good to know. Okay, we have one question in our Facebook Live. Is it possible to apply for any business used cases?
Actually, there's some use case in US. So mobile phone operator itself provide this data in aggregation forms. So it means they aggregate the data to a certain level. Let's say at the districts or province levels or at the grid level. And they provide like dynamic information about the people. So you see that, okay, this grid in the business centers, then how many population at 1 a.m., 2 a.m., 3 a.m., at 8 a.m., something like that. So they provide such kind of information to the business. And then the business just use that data to see whether like, okay, if they want to open the shop, so how many people will come to that area at what or at particular times, something like that. And then it can be associated with certain profiles. But the data is provided in terms like not the individual level. So you see the grid, one of the grid at location, and then you see total population, you see the proportions of male and females, age, range, and then the occupation, something like that. So I see that some of the mobile phone operators provide that kind of the data as a kind of the value added service, but not from the government itself, because for the government or from the regulators, I don't think they can do. But for mobile phone operators that they are enterprise company, they just want to earn something.
And what other mobile big data application do you recommend? Businesses, okay, one, then we learn about COVID, and what else you recommend to use mobile data for?
We also doing something on the transportation. For example, the government, there's one case that World Bank provide World Bank provide the fund to one country to build up the new road, and then they want to see or want to see the effect of that new road. So we want to see whether like the people actually use that new road trunk or not, based on the movement of the CDR data, something like that. And then like when there's something happen, or like some, for example, very huge disasters like a thunderstorm or like heavy snows, so we can use to check the people that affect in particular areas also, something like that. And for economic as well, we can use to see the economic impact, even for the COVID-19. But usually what the World Bank do is that they use CDR data to analyze the economic impact, and then for the internal migration to see how the people migrate from location to location, something like that. And then that can infer to certain indicator for SDG as well, something like that.
Yeah. Dr. Chairath, do you want to say something also?
It's okay.
Okay, yeah. So we know about like, okay, mobile big data can be available and applications can be there, but what are the sources of errors and which can be handled and which cannot be handled?
As you know that we are talking about the big data, right?
Yeah.
So when we're talking about the big data, the size of the data that we are talking is not 100 megabytes. We are
Yeah, of
talking is
course.
500 gigabytes. So with that file size, you cannot open, right? You cannot open on even your PC using any software. You cannot open and see whether like, okay, this column is missing or something. So that means that when you work on the big data, you have to keep in mind that they will contain the errors. There are always issues in the data. Some part of the data might be missing. Some of the data might be duplicate. Some extra attribute also might happen. So that's why every time we have to do the pre-processing. So we import into the big data cluster and we do pre-processing. And then with the pre-processing, we have to check, for example, then sometimes we found that, okay, one person having 100,000 calls in the day. It's impossible, right? How can people make 100,000 calls?
Yes.
So that probably that numbers or that ID is not the human. It's probably kinds of like gateways or like an IP phone or something. So that is not the real human. So we have to filter that data out from the data set. Yeah. That is very common, and then that we can do.
Yeah.
Something.
So outliers like this kind of stuff. Okay.
Yes.
Very big outliers. Yeah.
Yes, we have to remove from the data set so that we have the ordinary people. Sometimes we found that there's so many data in particular day, and usually it linked with like certain activity. For example, they have like really big events or really special holiday in particular countries. So the data usage will increase a lot. So in that case, we can know. And sometimes but recently, for example, we have like 2 weeks really high peak data, and then we could not know how that possible. And then in that case, we cannot, usually like when we see the peak, we can link with certain event, but sometimes we could not find the case. So that is something that we cannot solve. But we believe that when we check everything, the data is actually correct. So people just use more phone during that period of time. But what reasons, we don't know. Something like that. So at that case, we cannot fix the issues. Something like that. So there actually are so many cases.
Yeah. Okay. Yeah, I understand. Yeah. So I think we are running out of time, and we'll just take last question. I think Dr. Chairath want to ask something. Yeah.
Yes, maybe I ask on behalf of all the participants. So if they would like to know in detail, or if they're interested in this big data research topic, or they want to join AIT, could you please tell us a little bit more about facilities and that AIT provided or offer to RS&GIS students for processing and learning about those kind of technology, such as hardware, software, or any courses, or maybe even on connection for study abroad related to big data. What do you think about that? Yeah.
I'm still not sure whether like we can still go abroad. we have to fight with the COVID first. But anyways, like usually in AIT and RS&GIS, I having one course called Geospatial Data Processing and Management, and then in this one I also teach about the big data and also cloud computing in this class, and also like having some lab as well. So student also, even like maybe some of the like AIT student also join this live, so they can plan to register my class as well. And for the facilities, it takes some time to build up the platforms, but right now we have the Hadoop clusters that quite big enough. So basically we have almost 100 cores and over 20 terabyte of storage. So students can use that cluster to analyze the big data. So they just need to find some topics, and then they can utilize that kind of the machines. And not only the big data, so we have like we have deep learning machines. So that having very good graphic card that you can run deep learning models very fast as well. So we're trying to provide this kind of facilities so that it not block up students to do the research. Okay.
Thank you so much, Dr. Apichon, for your time and then such an interesting talk today. And Dr. Chairath for joining us and then sharing your experiences. I have a small announcement to make for our participants here. So I'm sharing my screen now. So we are planning to do a like live session with our prospective students who are interested to join us to study in AIT, RS&GIS. To tell you, the admissions are open and we will be having a live session on next Thursday on 21st January from 5 p.m. to 6 p.m. In the evening, Thailand time. So you can know about your timeline. And we will be talking about briefly on the full and partial scholarships and other opportunities and in RS&GIS AIT. So I hope to see some of you who are interested to join AIT for your further studies. So till then, this is Dr. Chutni Majumdar signing off from RS&GIS AIT. And thank you so much all the viewers and then Dr. Apichon and Chairath again for joining us today. Thank you so much.